Okay, folks, this will be a solution video for question 4, problem set 2. So this is the question that I assigned you guys to do for the paper assignment. I'm just going to do the derivatives for the other functions, the ones I didn't assign, just to kind of show you maybe what I'm looking for or some different ways that we might approach these things. All right. So this function g, I see it's a product, right? Product, I've got square root of x, cosine of x, so I'm multiplying two functions. So I've got to use the product rule. So there's a couple different ways I could go about using the product rule. I could call one of these functions f, call the other one g, find each derivative kind of on the side, and then use my regular product rule with the pieces called f and g. So that's fine. If I want to do that, I might consider renaming my original function. So that's one way of approaching it. Another way is kind of just apply the product rule. Maybe I'll use some denotation to apply the product rule term by term to let you know which derivative I'm going to take and then work it out that way. So let me try it that way. So I've got my function g, so let me just go ahead and say g prime. All right, and so I'm not going to be renaming these f and g the way we did in class. I'm just going to go ahead. The derivative of this function g is just going to be called g prime. And I know when I'm taking the product rule, I've got to take the derivative of one of the functions and multiply that by the other original function, and then add that product to the reverse of that, right? So I can kind of choose which one I want to take the derivative of first. So let me take the derivative of this guy. So I'm going to say d dx of square root of x. So that's the derivative of the first function, and then times the original second function, cosine of x. All right. And then from there, I'm going to add that to the original first function, square root of x, multiply that by the derivative of my second function, d dx of cosine of x. All right. This is a nice way of doing it because I'm kind of demonstrating the product rule, and I'm not jumping too far ahead. I'm not skipping this step and just writing what the derivative of cosine is, which I'm going to write in the next step, but this kind of illustrates to the reader what steps have been done, okay? So sometimes when we write stuff up, I use that phrase a lot, for the reader. I'm the reader, right? I'm grading it, but don't think of your written work as something that's going to get graded. Think of it as something that you're writing that somebody else is going to read, and is every step going to be clear, right? That's the goal. So indicating sort of what we're about to do is helpful. And now from there, I'll just continue along, and now I'm going to actually evaluate these derivatives. All right, so we've got the derivative of square root of x. So I'm familiar with this derivative. I know that it's that, okay? Do we have to show the work to do that, to get that here? Perhaps. So you might have committed this to memory. Let me just kind of show on the side how that works. So square root of x, we know, is the same as x to the 1/2. All right, and then so if I'm gonna work out the derivative of that, let me call this y, then I could just say y prime is equal to 1/2 x to the negative 1/2, and then we clean that up, we put the x down to the denominator, so 1/2 x to the positive 1/2, and then x to the positive 1/2 is my square root of x. All right, so if you feel like you want to show that on the side, or kind of in the context of your work, you can do that. We've covered this one in class, so eventually you may commit this one to memory. So I'm just going to leave it like that for now. Multiply that by, this guy doesn't have the differential operator in front of it, so I'm not taking the derivative. So just multiply that by cosine of x. And then moving right along here, I've got regular square root of x, not taking the derivative of that. And then we're told to take the derivative of cosine of x, okay? And similar to what I did over here, I know the derivative of cosine of x, right? We've worked it out. Eventually you want to commit it to memory, refer to a table or something like that. So unless we're explicitly being asked to find that, show all the work, we'll just take it for granted. So I'm just going to do this. So minus, I'll multiply by, and the derivative of cosine is minus or negative sine of x. All right. And that's it. So right there, we've applied the product rule. So technically what we're looking at right there is the derivative. So you could say we're done, but typically I want to clean things up as much as I can, or a little bit anyway. Clean up these products. Maybe we can kind of clean something up. So let me do like so. So I've got 1/2 root x, and then I'm multiplying that by cosine of x. So that cosine of x really lives over a 1, and so maybe I want to unite that with this one by putting the cosine up top. So I can sum up this whole product here by writing this cosine of x over 2 root x. Right, that looks kind of nice. And then over here, I'm adding here, but I'm going to multiply these two quantities. And this one's got that minus sign in front. So maybe instead of multiplying or adding a negative, let me sort of convert that into subtraction. And then I've got root x, sine x, root x times sine of x. And that looks good enough to me. I think I cleaned that up a little bit. At least I kind of brought these terms together, kind of brought that minus sign out front. Could you go further? Yeah, I mean, could you rationalize this denominator? Maybe that's something you've done in the past. Could you combine these two functions or combine these two expressions through the subtraction? That might be nice sometimes. So if you wanted to kind of clean this up, things might sort of fall out or really clean themselves up nice. So that might be something to think about, but I would say if you're asked to find the derivative of a product, and so you took the derivative, you got to here, this looks pretty clean, this is probably a decent final answer. All right. Let's think about if we wanted to clean that up, because now I'm just curious to see if I were to go further. So I'd probably stop there, box that as my final answer, but I just kind of piqued my own curiosity. Let me try to combine this and see what we would end up with. So the reason I want to do that is to see, is it really cleaner or what? So I need to, if I want to subtract these things, I need to get a common denominator. This thing really had no denominator, so you could argue there's a 1 living down there already, but I need to multiply by a 2 root x down there to get, so I can do my subtraction, and then that means I've got to multiply the top by a 2 root x. If I had a plus sign here or something like that, I would definitely wrap that in parentheses, right, since I'm about to multiply. But I'm just doing multiplication on the top of this fraction anyway, so I can just do multiply by 2 root x up there. All right. So just to kind of clean this up in place, now that I've got my common denominator and I'm subtracting, that means I can just sort of subtract those two numerators over that common denominator, right, which was 2 root x. And let's see if the top cleans up at all. So I had a cosine x over here by itself. Here I've got a root x times that other root x, so I can multiply those together and just get a regular old x. So that's kind of cool, and I got the 2 coefficient. Maybe I'll bring that stuff up front. So 2 and my x and my sine of x, so 2x sine of x. There we go. So it's debatable if this looks cleaner than the other one, so I would probably stop what I did earlier if you're debating at home what to sort of submit. But this looks kind of clean to me. Notice I can't cancel any kind of 2's because I can't factor 2 out. If I wanted to rationalize my denominator now, how would I go about that? I can multiply top and bottom by square root then of x, then that's going to get distributed over here though. So anyway, I'm kind of going a little bit too far, so I probably would have stopped a little bit earlier. But set up your product rule, carry out the derivative, clean it up a little bit, 100%.